Hi everyone. I'm gonna try and make this short because I already recorded it a couple times and it stuck on me. So today we're gonna be talking about L'Hopital's rule. And the pronunciation looks like La Hospitals, but the pronunciation, at least from most mathematicians I hear, is L'Hopital's rule. L'Hopital's rule is a helpful tool for finding limits that you can't find by just plugging in a number. That's the best case, or you can't do any algebra to get out of them either. It's a great tool to use if you can use it. Okay. So let's look at this example. We did this example, but we solved it by making a table of values and guessing what the limit was. So, for example, we plugged in, to make a little table, I'll just plug in a couple of values. So if I plug in negative 0.001, something close to 0, but from the left, I got 0.99999. Okay, I'm just plugging in a few values, so let's say 0.001, something close to 0, but from the right-hand side, and we get 0.9, a bunch of 9s. Very close to 1. Okay, and so we plugged in values closer and closer, you guys did, and got that we estimated that the limit must be 1. Okay, you can also look at the graph of this and estimate that the limit must be 1. But there's another way. And that's L'Hopital's rule. And we're just going to do the version 0 over 0, determinate form 0 over 0. So this is the rule. Simply put, limit as x goes to c, if you have something like this, f of x over g of x, and both the numerator and the denominator go to 0. So if you have the limit as x goes to c of f of x equals 0, and the limit as x goes to c of g of x equals 0, then this limit is equal to the limit as x goes to c of f prime of x over g prime of x. And so this expression, f prime of x over g prime of x, is often a lot simpler than the original problem. Because we know when we take derivatives, generally they get simpler. And like if you take a derivative of a polynomial, you keep taking derivatives of it, eventually you get a constant. So that's the simplest thing. So there's some hope here that we might be able to solve some limits that before we couldn't. Okay, so let's try it on this problem. So but the main thing is that you can only use it if you have that form 0 over 0. So let's keep that in mind. Okay, so limit as x goes to 0, sine x over x. First, try and plug in the number. That's always a good strategy when you're finding limits. Try and plug in the number. So try and plug in the number. Sine of 0 is 0. Plug in 0 to the denominator, we get 0. So this does have indeterminate form 0 over 0. So we really do need it. Basically, the thing is, don't use L'Hopital's rule unless you need it. Okay. Otherwise, it will get an incorrect answer. Okay. So now take the derivatives. And I just want to mention that this has nothing to do with the quotient rule or anything, because I'm not taking the derivative of this entire expression. I'm just taking the derivative of the numerator, derivative of the denominator. Derivative of the numerator, cosine x. Derivative of the denominator, 1. Okay, then go back to the original first step. It's always the first step when you're finding limits. Oh, the first step is always try and plug in the number. Okay, try to plug in the number. Cosine of 0 is 1. So this is cosine of 0 over 1, which is cosine of 0 is 1. Okay, so maybe use your unit circles. Great. Okay, so this problem, now we feel validated because it really is 1. The limit really is 1. Okay, let's try another example. Okay. Limit as x goes to 0, e to the x minus 1 over x squared plus x. So first, try and plug in the number. We might get lucky. It might be a continuous function. So plug in the 0. So e to the 0 minus 1 over 0 squared plus 0. E to the 0 is 1. 1 minus 1 is 0. 0 plus 0 is 0. So this is indeterminate form 0 over 0. And that's how you can show your work too, that you're going to use L'Hopital's rule when you actually can use it. Okay, so let's find this limit. So this is limit as x goes to 0. The derivative of e to the x is e to the x. The derivative of 1 is 0. The derivative of 2x plus x is 2x plus 1. Okay, now go back to the original beginning of the problem when you try and plug in the limit value. So plug in 0, so e to the 0, 2, 0, 1. E to the 0 is 1. 0 plus 1 is 1, so the answer is 1. Okay. And if you find that when you plug in the limit value after you use L'Hopital's rule once and you get again this indeterminate form 0 over 0, feel free. You can use L'Hopital's rule as many times as you can, as long as you can. You can use it whenever, as long as you have the indeterminate form 0 over 0. Okay. There's another indeterminate form, but I'm not talking about that right now. Also, it doesn't matter if it's a limit from the left or the right, you can still use L'Hopital's rule. Okay, let's do another example. Sine of 7x over x. Okay, this one's similar to the other one. So first check if I can use the rule, or just try and find the limits. The first step is always to try and plug in 0. Try and plug in the limit value. So sine of 7 times 0. So sine of 0 is 0, and the denominator is also 0. So 0 over 0, we can use L'Hopital's rule. So now take the derivative of the numerator. Derivative of sine of 7x is cosine of 7x times 7. Right, that's a chain rule. So the derivative of the outside is cosine, and the derivative of the inside is 7. And the derivative of x is 1. Now plug in 0. So we get cosine of 0 times 7 over 1. Cosine of 0 is 1, and so this answer is 7. Okay, and finally, let's do what happens if you use L'Hopital's rule when you're not supposed to. Okay, let me show you an example. We call this a non-example. Okay, let's say I'm working fast and I just love L'Hopital's rule so much that I want to use it all the time. Okay, so let's say I didn't do the first step, but you have to check what happens if it goes wrong. Okay, so let's say I just tried to use L'Hopital's rule incorrectly here. Okay, let's say I just take the derivative of the numerator, 2, take the derivative of the denominator is 4, so this is 1/2. This is not correct. Okay, let's see why. Well, because I skipped the first step. You can only use L'Hopital's rule if you have the indeterminate form 0 over 0, or infinity over infinity, but we're just talking about 0 over 0 right now. So try and plug in the limit value. So always try and plug in the limit value. So 2 times 3 plus 7 over 4 times 3 plus 1. So it's 13 over 13, so this is 1. And that's the correct answer for this problem. It's 1. So L'Hopital's rule is wonderful when you can use it. If you can't use it, that probably means you can just find it by plugging in the limit value. So always plug in the limit value first. If you get 0 over 0, go ahead and use L'Hopital's rule. If you don't get 0 over 0, use something else. Well, that's all I can say for now. All right.